Hey everybody, so we're back talking about some polynomials here. So here's the next thing that I want to talk about. Let's just start with a problem here. I want to come up with an equation for this function. So if you want to pause the video and graph this real quick. So we have x-intercepts at -1, +1, +3, and we have a y-intercept down here, -1. Okay? And we want to come up with an equation for this polynomial. So if you guys watched the video over the weekend, the first thing that we did is we took our x-intercepts. So we have x equals -1, x equals +1, and x equals +3, and we turned those into factors. So we came up with x plus 1, x minus 1, and x minus 3. Okay? And then we threw a k, or you pick your favorite letter out in front. That was our stretch factor. And so that's going to have us come up with our y-intercepts. Okay? So let's go ahead and throw this in our calculator real quick. So if you take this and you graph this, it's not going to give you what you want. Okay? And if you want to pause the video and do that real quick, you're welcome to do that. But why doesn't it give us what we want? Well, what's the degree of this? Is this an even or an odd degree? Well, it looks like touchdown. So this is an even degree polynomial, right? But take a look at our equation. If I were to distribute all this out, which I don't want to, but if I wanted to, think about what this would look like. This would be x cubed plus blah, 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 blah. Because we do x times x and x times x times x, and we'd end up with x cubed. So the way I have this equation written, this is actually an odd degree, but my final needs to be an even degree. So what's the deal here? What's the matter? Or how do I get this to work? And so something that we need to talk about is, if you look at this x-intercept here, do you notice how it comes to this x-intercept and it hits it, and then it turns back the other way? Do you guys see that? And so before we solve the rest of this, we have to take a few notes on some different types of things that could be happening around our x-intercepts. So if we see something like this, I'm going to call this a hit and run. So if you see one of these hit and runs, or sometimes you'll see it in a textbook as a touch and go, or what are some other ones? I don't know. I think hit and run is my favorite though. So by hit and run, what I mean is, if you have an x-intercept and the graph approaches that x-intercept and touches it, and it goes back the other way. That's what I mean by hit and run. So it's still an x-intercept, but it doesn't cut through the graph. It just stays going through. Okay? So what you maybe remember doing with this last year is, we're going to say as an even multiplicity. Okay? And if you don't remember this, that's okay. You don't write this down. But you remember solving equations, and it was like, what did you do? I don't know. I don't know. You're solving for x like this, and you're solving a quadratic. So remember, you're supposed to come up with two solutions. Remember that. So if you solve this, well, if I need two solutions, how am I going to come up with two solutions? And the way maybe you did this was, you just said like x equals 2, and then maybe you put a little m2, multiplicity of 2. Okay? And some of you guys have seen that before. Some of you have never seen it before, and that's perfectly fine. It's not really that big of a deal. Okay, but this is where you maybe have seen this before. But what that's going to do to our function is, if I have a hit and run, or a multiplicity of 2, or an even multiplicity, or however you want to say it, all we're going to do is, we're going to take this factor, x minus 1, and we're just going to put a little square up there. Can you guys see that? Sorry about this glare. It's 7 a.m., so it's too dark to turn both lights off. Okay, so we just put a little square up there. So that's how we're going to deal with that. Now, there's another thing that you might see. And another thing you might see is, the graph might flatten out as it approaches the x-intercept. All right, so what that might look like, kind of like our cubic function, is the graph comes down, and instead of just going right through, it kind of flattens out and then keeps on going. So it looks kind of like a cubic function. And then maybe this doesn't go on for forever. Maybe it comes back up, and then maybe eventually it has another x-intercept over there or something. But this point right here, when it flattens out, this usually is like a multiplicity of 3 for our purposes. Technically, it could be or any odd number, not including 1. Okay, so if it's a hit and run, this is an even multiplicity. For our sake, usually we're just going to go with the multiplicity of 2, but it could be, you could put like a 4 up there, and that would be fine. It could be to the 4th power. Kind of depends on the function there. Okay, and if it just goes straight through the graph, like this x-intercept, it just goes right through, then we just have the multiplicity of 1. Okay, so here's the gist for what you need to know. If it flattens out, which I'm not going to give you too many of those because sometimes it's kind of hard to tell, so I'm just informing you that it exists. But if it flattens out like a cubic function, then we would put like a little cubed up there. Okay, it'd be whatever our factor was cubed. So if I wanted to write the equation for this function, let's say there's an x-intercept over here at -4, and this is an x-intercept of 1. So this would be x plus 4, because it goes straight through at -4, and then it flattens out at 1, so it'd be x minus 1, and since it's flattening out, it'd be to the 3rd. And you can see how that would make sense, because the degree of this function right now is 4, which makes sense because my graph looks like this at the end, so we knew it had to be an even multiplicity. Okay, so hopefully that makes a little bit of sense. All right, so let's go back to our original problem here. So now we have some more knowledge. We can go ahead and come up with an equation here. So we have a hit and run at 1. So I took my x minus 1, and now that factor is squared. So that's great news because now it's an even multiplicity, and that's how we're getting our touchdown pattern here. Okay, so now all we got to do is solve for this k. So to do that, I'm going to use this extra point that I have. My y-intercept is -1. So -1 is my output when 0 is my input. All right, now this is where you're going to mess up if you mess up, is you're going to forget, you're going to remember to put the square there, but you're going to forget to put it down here. So make sure that you don't lose your exponent there. So now -1 equals k times, so 0 plus 1 is 1. So -1 squared is +1, and then times -3. So 1 times 1 times -3 is -3. Divide everything by -3. So 1/3 equals k. So my final equation is f of x equals 1/3 times x plus 1 times x minus 1 squared times x minus 3. So there's my equation. Okay, so hopefully that makes some sense. Hopefully you can see that. So I'm going to erase my board, do some examples, and then we'll get back together here in a second. All right, so here's an example. We're going to kind of up the ante a little bit on this one. So the first thing I want to do is come up with an equation. Okay, now on this one, instead of giving you the y-intercept, I'm just going to give you some random point that's chilling over here and see if we can come up with the equation here. Just in case you have a hard time seeing, we have an x-intercept at -4. It's just a normal x-intercept. And then we have a hit and run at +1. Okay? So a couple things I want to do here. I want to come up with the equation. That's the first thing I want to do. And then once we have the equation, I'm going to ask you a couple other questions. And I want to know what are my maximums or minimums. I want to know them all. So we're going to get into more detail once you guys are back in person with this. But something that we want to know is, okay, I have a graph. That's great. I can come up with an equation. That's fantastic. But once I have that equation, now I can do all sorts of stuff. So we're going to start by just finding max and mins. When you guys get back in class, we're going to talk about like where's the graph increasing, where's the graph decreasing, what are the x-intercepts, what are the y-intercepts, stuff like that. We're going to talk about something called concavity. Where is it concave up? Where is it concave down? So in order to do all that, we need the equation. And then we're going to take it one step further, and we're going to figure out where are my max and mins today. Okay, so I can see it. This one, I think I know is a maximum at the coordinate 1, 0, but I don't know what this minimum is, and I don't have a good way of finding that unless I have an equation first. All right, so start with the equation. So remember, my process is figure out my x-intercepts. So -4 and +1. Turn those into factors. So x plus 4, and then x minus 1, and it's a hit and run, so that's going to be squared. Okay, now finding this k value. Well, all the other problems we've done, we had a y-intercept, and so we plugged in 0 for x, and we plugged in whatever the y-intercept was for f of x, and we came up with our equation. But now I don't have a y-intercept, but I do have this other coordinate, 2, -2, and that works just as good as my y-intercept. But how do I use it? Well, this is x, f of x, so I'm going to plug -2 for f of x, and plug in +2 for x. So it's the same exact thing that we've been doing. It just, the algebra is a little bit harder, but not really that much harder. All right, so -2 equals k times 2 plus 4 is 6. 2 minus 1 is 1. 1 squared is still 1. Divide both sides by 6. So -2 divided by 6, I think that's -1/3. All right, so k equals -1/3. So that means my equation is f of x equals -1/3 times x plus 4 times x minus 1 squared. And I feel pretty good about this equation because look at my original graph. So it's cubic, so it should be a degree of 3, which ours is. 1 plus 2 is 3, we have a degree of 3. And it looks like this, which is a negative leading coefficient, so it makes sense that I got -1/3. Alrighty, so now I want to know these max and mins. So I already know this one. So I want to show you how I'm going to ask you guys to write these. So last year you maybe just wrote them as a coordinate, which is fine. It's okay. But in pre-calc and calc world, we're going to try to be a little bit more sophisticated. So we're going to say f, that's the name of our function, has a local max of 0 at x equals 1. Alright, so what the heck does all this mean? First of all, what is a local max? So a local max means that in this area, it is our biggest value, but it's not the highest point on the whole graph. So if it was the highest point on the whole graph, we would call that a global maximum. And here's an example of what a global maximum will look like. So this would be a global maximum because it's the highest point on the whole graph. Okay, so this is called a local maximum. All right, now what about this guy? Well, to find that, we're going to use our calculator. So I'm going to grab my calculator, and I'm going to type my equation in. All right, so I got my equation typed in. You can't see the whole thing. That's okay. So I'm going to hit graph. And I get this lovely curve here. That's what it should look like. Uh-oh. My battery just died. Okay, and then we're going to go second, calc, minimum, and then it's going to ask you to go to the left. So you're going to click, 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 and hit enter. Then it's going to ask you to go to the right, click, 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 enter. And then you're going to take your best guess and hit enter again. And what does it tell you? Okay, so my calculator said this is my minimum. This is the point, -2.333, comma -6.173. So how do I write that? So we say f has a local min of -6.173, and that happens at -2.333. Okay,